In this demo, we will see innovation in action as we explore the multimodal capability of our next generation AI platform, combining classical machine learning, computer vision, privately hosted large language models, and time series analysis to solve a critical challenge in the insurance industry. So our first use case involves building an ensemble model, which you can see on the screen, to predict car insurance premium from different set types of data. This model integrates machine learning for tabular data such as driving history, claims history, a CNN model for car condition image data, and a time series model for fixed overhead charges. So in the first part, we will go ahead and ingest our data from our database. So let's first start by building our classical machine learning model using FNN, feed forward network. So this is the data that we have ingested already. You will see driver related attributes, vehicle related attributes, all of them here. Again, we can see the summary, we can see the preview, and the yearly premium. The last column that we see on the screen is what we are going to predict as a supervised learning model. So after having a look at data, we can again do the same thing with auto EDA, which I just showed in the previous demo. So I'm not going to repeat here again. Then we will do the data preparation. So here again, we need to do duplication since we have some duplicates in the data. We need to do feature encoding and data scaling. Scaling is particularly very important in this case because we have the indication that we want to use the uh, feed forward network, neural network. In the previous demo, you have seen how are we trying with setting up the experiment. Here we already have a model that we have selected. And for that, we need a particular data pre-processing step to be done. After that, we can also write our custom code here. So this is one functionality which gives you agility and flexibility to uh, include any library, any Python library. Now let's look at our pre-built model that we have already built. So here you will see multiple different layers of neural network along with the total parameters. So here we are just trying to fit 3777 parameter to be precise. After having a look at the model, we have the test data pipeline also ready because we have split the data into train and test. And now we are going to use the predict node to be able to predict and then finally evaluate the model. And as I said, this model we have already tried out in the experimentation phase, and this is our champion model. You can see the R square value is pretty neat, right? So 0.93, which is a measure of good fit, I would say. Now, after looking at the metric and being satisfied with this particular model, let's move on to the next dimension, which is the image data. In the same workflow where we have just read the tabular data and created a model, we can also ingest the image data using our image data, read image data node. And this is, we can also look at the preview of the data. So let's look at some of the car images. So these are like high risk damaged car images. And then after looking at it, finally we will go back and we will do some feature pre-processing again for image data. And here also we are doing the encoding, and finally we are going to use the image classification node. So out of the box we have two computer vision functions available. One is image classification, another one is object detection. So when you are trying to detect a custom object, multiple object in one image, then you have to use object detection. Here we are going to classify the image as high risk or low risk. So we have selected image classification. The next is to select the which particular model we want to use here. So here we are going to use MobileNet V3 small, since we have not selected GPU right at the start. And then finally we can set up general parameters like epochs, batch size, etc. Loss function, very important. Or else if I want, I can also go into advanced parameter and I can try configuring each of the layers of my CNN model separately, how I want to handle the transfer learning task, right? Once I train the model, this is how the model summary will look like. So in model summary, uh, yeah, so now model is ready and here is the model summary. So here you will see 900,000 parameters has been trained, and this is the difference between classical machine learning where you have few thousands of parameter versus computer vision where you have few hundred thousands of parameters, and in generative AI you will see that there are billions and trillions of parameters, right? And now I will move back. Since my model is ready, I can use the unseen image to predict based on the data that we have, blind test data that we have kept without showing it to the model. And then finally we can combine the result. But before we combine the result, we will go to the third dimension, which is time series analysis. So here we have created a simple auto arima model to predict the overhead charges for a particular company. Things like expense ratio, things like inflation needs to be adjusted in their premium, right? So for that we have some historical data of last 10 or 15 years. Using that historical data, we are trying to train a time series model here. So this is how your data looks like. This is just a univariate time series data, and then we have trained our auto arima model. You can see the model summary again on the screen. So it will, since it is auto arima, it is going to select all your PDQ value uh, automatically. We don't have to think about a stationary and all those aspects of time series data. Now, after that, I will again predict on unseen data for next few years using time series model. And finally, it's time to create a heterogeneous heterogeneous ensemble model to finally get the output here. And this is how our final premium will look like. And again, we can do the entire MLOps, which we have seen in the other demo, in this case as well. Now let's quickly jump onto our next use case and explore this innovative use case from the insurance industry, where we have privately hosted the multi-language model, multimodal large language model. The problem was to detect anomalies such as duplicate in voice and also enable user to interact with the voice data in natural language. Invoices are often unstructured in nature, and hence classical OCR like Tesseract will not work here, right? It would not suffice. Instead, we decided to use LLM with vision capability, since we could not have. Now another complexity is that we cannot send out the data outside because this is IP data. So we cannot use a multi-model vision model which is hosted outside our premise. And that's where uh, we have used Llama 3.2, which vision capability, which was just released for solving this use case. So we and that is the region we have extensively used Jupyter Notebook here, because since we had to write all the code at our own, there was no pre-built library since Llama 3.2 was just released. So here we will read some parameters using read data node, and then we will just transfer those parameters to Jupyter Notebook, and the entire code is written in Jupyter Notebook, which also shows that you can not only use the low code part of this platform. If you have to solve a complicated task, you can write your own code, and this system will give you the complete flexibility to integrate any new advancement in generative AI or in machine learning field. So there is no boundary as such of what problems you can solve using tcgmcube AI 2.0. Now let's quickly look at how my data set is looking like. So I will show you one or two invoice here. So this is how invoice looks, right? So this is a scanned document, but at the same time, there are some structure inside it, which needs to be preserved if you want to effectively query this data and effectively extract the information from this data. And that was the main reason we wanted to utilize the vision model. So we have used, as you can see here, we have used Meta Llama 3.2 11 billion parameter vision instruct, along with E5 Mixtral for creating the embeddings. And we have inbuilt in Elasticsearch inside tcgmcube as our vector embedding storage. So this model not only extract the information, but also structure the data in a way that you can ask questions to the data. So this is how the output structure looks like that you see on the screen extracted from the data. And now I will quickly show how we can ask questions and which type of questions we can ask from the data. So for example, for the invoice this and registration number this, what is the total of part for the total column? And again, LLM is able to calculate and give us the answer for this part as well. This use case was particularly very exciting because Llama 3.2 was released on 25th of September, and within a week's time, we were able to do this pilot and show the value to our end client. And this is how we truly bring the velocity in delivering the value using TCG MQ. Thank you.